Let's take a look at radii of curvature for different lenses and step through how do we figure out which radii are positive and negative, how do we figure out which is side 1 and side 2, and look at what changes and what doesn't change when light approaches the lens from a different side. So here we have two diverging lenses. They are thin in the middle, fatter on the ends. And the first thing that we need to do is choose a direction of incoming light. So let's have our incoming light coming in from the left. That is going to define the left side of our diagram to be the virtual side and the right side to be the real side. Virtual is always the side that light comes in from. We also define side 1 of the lens as the side the light will hit first, and side 2 as the side that light will hit second. So the left side is side 1, the right side is side 2 in this diagram. Now for the radii of curvature, I'm going to do something a little bit funny here, but hopefully it'll stick in our heads. So I'm going to picture this side of the lens, looking at side 1, as being a little mouth. So we've got some teeth and an eye, and this mouth is opening towards the virtual side. The virtual side is always the negative side in our diagrams, the one exception being object distance, but we're not worried about that at this moment. Since the mouth opens towards the virtual side, R1, the radius for side 1, is going to be negative. Looking at side 2, the mouth opens towards the real side, so R2 would be positive in this diagram. So for the top diagram, we have our incoming light defines virtual and real sides. It defines side 1 and side 2, and then based on which side the mouth opens towards, that tells us whether it's negative if it opens towards the virtual side, or positive if it opens towards the real side. Now below, let's consider what if light came in from the other side. Well, if light comes in from the right, now the right side down here is our virtual side. The left side is our real side, because virtual is always the side that light comes from. We've also changed which side of our lens is side 1 and side 2. Side 1 is always the side that the light hits first, so now the right side is side 1, and the left side is side 2. Using our mouth idea again, side 1, R1 opens towards the virtual side. Side 2, that mouth opens towards the real side. So we still have R1 less than 0 and R2 greater than 0. However, what changed is now the right is side 1 and the left is side 2. But it is still the same type of lens, and if we worked through the math, we would get the same focal length. This lens has a certain focal length, regardless of whether light comes in from the left or comes in from the right. Now let's look at our classic example of converging lenses. Again, I have to start by picking a side for light to come in from. So if light comes in from the left side of the lens is side 1, the right side of the lens is side 2. Left side of our diagram is virtual, right side of our diagram is the real side. In this case, side 1, here is my mouth. It is opening towards the real side, so R1 is greater than 0. Side 2, the mouth opens towards the virtual side, so R2 is less than 0. If light came in from the other side, then we would have our virtual side on the right, our real side on the left. Over here, this would be side 1, and this would be side 2. And we would again decide that side 1, the mouth opens towards the real side, so R1 is positive, and R2, the mouth opens towards the virtual side, so R2 would be negative. So again, for both lenses, when we switched which side the light was coming in from, that changed what we called side 2 and side 1. These two labels switched. But the definitions of whether R1 was positive or negative did not change. Just what side of the lens it was referring to did change. And if we actually worked through the equations, we would get the same focal length, no matter which side the light came in from. This is why in some of the problems, you'll see a problem where it just shows you a lens and gives you radii of curvature, but it doesn't show which side light comes in from, is because if we're asking for the focal length of this lens, we will get the same focal length whether light comes in from the left or whether light comes in from the right. So if you're solving this problem, you need to pick a direction for light to come in from so that you can define your real and virtual sides. But it is up to you. If you pick light to come in from the left or to come in from the right, you should get the same focal length either way.